Customers that had trialed or used Elemix additive in concrete slab applications noticed a reduction or absence of plastic shrinkage cracking. To quantify the behavior noticed in the field and in internal tests, the Elemix additive team then pursued third-party research. All concrete cracks eventually, but the object of design is to meet physical requirements and to minimize cracking. Cracking can be the result of drying shrinkage, thermal contraction, restraint, subgrade settlement, applied loads, and other factors. Some types of cracking may just be a visual nuisance, but other types of cracks may compromise the durability and service life of concrete structures. Understanding the behavior of raw materials can result in producing concrete with enhanced durability and longer service life of concrete structures. To determine whether Elemix additive, a lightweight synthetic particle or LSP, helped improve concrete performance by reducing cracking, research was conducted at Purdue University under the direction of Dr. Jason Weiss. Concrete mixtures with various percentages of LSPs were tested, following ASTM C1579 standard test method for evaluating plastic shrinkage cracking. Samples were cast in triplicate in accordance with ASTM C1579 and were transferred within 30 minutes of mixing into a controlled environment for analysis. Weight loss and plastic shrinkage cracking was monitored for the first 6 hours, and then the samples were sealed and stored until 24 hours of age was reached. Crack measurements were then performed at 24 hours from the time of mixing. 4 types of LSP were tested. The test results show that the use of LSP provided a reduction in plastic shrinkage compared to the control mixture. The results generally demonstrate crack reduction ratios between 40% and 70% and were dependent upon the volume and type of LSP used. The results for commercially available LSP Elemix XE additive achieved 77 to 83% crack reduction ratio versus the control mixture. Part 2 of the Purdue University tests with Dr. Weiss investigated the use of Elemix additive to reduce restrained shrinkage cracking in mortar mixtures. Testing followed ASTM C1581 testing for restrained shrinkage cracking. The concrete mixture is cast around a steel ring, causing tensile stress to develop in the concrete when the concrete shrinks and is restrained by the steel ring. Stress relaxation due to tensile creep then occurs. Strain measurements taken of the steel ring are proportional to the stress in the concrete. When the tensile stresses in the concrete mixture exceed the concrete tensile strength, cracking occurs. All of the mortar mixes utilized Type 1 ordinary Portland cement and used a 0.30 water to cementitious ratio. 5 types of lightweight synthetic particles, LSP, were used in testing. Fine aggregate passing the number 16 size sieve and retained by the number 30 size sieve were replaced by LSP. Various volume percentages of each type of LSP were tested, up to a maximum of 18% absolute volume. The commercially available LSP Elemix XE additive resisted cracking an average of 73% longer than the control sample. With the addition of Elemix XE additive, the time to cracking was increased. Since a longer time to cracking usually results in smaller cracks, the delayed restrained shrinkage cracking seen with the use of Elemix concrete additive is a positive contribution to the overall concrete performance. As stated by Dr. Weiss in his report regarding the significance of this research, cracking may compromise the durability and service life of concrete structures. Understanding the behavior of alternative materials can result in enhanced durability and longer service life of concrete structures. A copy of the report, which details the research and results to a much fuller extent, is available upon request. In addition, the results of the restrained shrinkage cracking behavior of mortar was published in an article in the May 2011 Journal of Materials and Civil Engineering. Reprints of the article are available upon request.